We're very fortunate to have Professor Anasse Bari from the Computer Science Department giving our keynote speech today. Recently, Professor Bari won the Golden Dozen Award for his outstanding contribution to learning and research. He has a distinct passion and dedication for his students that has not gone unnoticed. Please give a warm round of applause for Professor Bari as he so graciously says a few words to us tonight.
I'm really honored to be with you here tonight, and I'd like to share with you some highlights of my story. I was born in a city called Tangier in Morocco. Tangier is the gateway to North Africa. It's a city where the Atlantic Ocean meets the Mediterranean Sea. Since the mid-50s, Tangier has hosted a number of artists, poets, and intellectuals, and it was influenced by Paul Frederick Bowles, who is an American writer, famous composer, and he influenced members of the Beat generation to come to Morocco and finish their project in Tangier, enjoy the sunlight of Moroccan couscous, and live the Moroccan dreams. And tonight, I would like to extend to all of you an open invitation to come visit me in Morocco in the summer. There are some requirements, minimum GPA requirements. That was a joke. I grew up in Morocco and I was a math major, and I studied computer science at the George Washington University, thanks to the Fulbright program. And in 2006, in a snowy day in Washington, D.C., I remember my first meeting with my PhD advisor, where he handed me books about birds. And he said, I want you to learn everything about birds, and I want you to learn how birds flock. And I want you to know the mathematics behind the beautiful birds flocking behavior. Keep in mind I was in the computer science department, and I thought at the time that I would never graduate, and I thought that my advisor, Professor Balatia, was a crazy man. It turned out there's a whole area under artificial intelligence known as swarm intelligence. And it's the science of developing algorithms inspired from nature, specifically from the beautiful behavior of flocking birds, the complex behavior of schooling fish, and the self-organized intelligence in colonies of ants, and the most orchestrated movements of bees. So I learned a lot about birds, and I learned that there are three main rules that orchestrate the flocking behavior. There is the separation rule, which keeps birds from colliding with each other. And there are the two other rules, which is the alignment and the cohesion. And those rules will allow the birds to move with the same speed and acceleration as the flock mates. Now, together with my former advisor and other computer scientists, we developed algorithms that were inspired from birds. And we applied them to model social networks. So we can represent human beings as birds flocking in a virtual space. And the purpose is to build recommendation systems that power Amazon, Spotify, Tinder, Netflix, and others. Since swarm intelligence is a subset of AI, let's talk a little bit about AI. So what is AI? If we look at the meaning of the two words artificial and intelligence, we can easily define AI as the opposite of human stupidity. But seriously, what is AI? I think this is a difficult question to answer, and I think there is a little consensus of what AI really means. And I would like to take you back to the year 1950, where Alan Turing proposed the Turing test, which basically states that a computer passes the Turing test. If we want to call this computer as an AI, if a human interrogator cannot tell whether the written responses to posed questions come from a person or from a computer. Ideally, a machine that has AI should have four main capabilities. The first one is knowledge representation. The second one is natural language understanding. The third capability is machine learning. The fourth one is automated reasoning. And these four capabilities comprise most of AI. And if we want the machine to ace the Turing test, it should have two more capabilities. computer vision to be able to see, and then robotics to be able to move objects. In 1985, Hofland defined AI as the exciting new effort to make computers think, machines with mind. And today, I define AI as an economically viable digital agent that explores, learns, acts, and can replace some easy human tasks. But it lacks common sense. Lack of common sense is a major weakness of AI. It is the most significant barrier between the narrowly focused AI applications we have today and the more general applications we would like to create in the future. In fact, there are two main types of AI. There is specialized AI and there is general AI, which is also known as super AI. Specialized AI is created to do one task and one task only, like predicting the weather or predicting skin cancer from medical imaging. General AI, as it stands now, is nowhere close to having human-like intelligence. However, while it's not a silver bullet, it could serve as an extension to our intelligence and can contribute to the many efforts to tackle some of the world's most challenging problems. And the most exciting thing is that it's happening right here by many of our students that I consider them always as my intellectual partners. So Jacques Wang, who is a CAS undergraduate who's now finishing a master's at MIT, was part of one of my research teams. And back in March 2020, in the earliest days of the pandemic, they used predictive analytics to build a computer tool that predicted who would get a severe case of COVID, a tool that helped doctors allocate resources. Shailesh Vasandani, who was a CAS student, continued on Jack's work, and he analyzed data for more than 14,000 patients in New York City and used AI to build a tool that would predict outcomes and make data-driven decisions for doctors. Ashish Kurchambani, who is a physics major and computer science major, he worked with another team during the pandemic, during the lockdown. They used natural language processing to build an early alert surveillance system to basically model the pandemic curve. Julia Wang and Robin Zhao, Ryan Cohen, they all CAS undergraduate students, they designed a real-time big data analytics tool to track vaccine hesitancy. William Brower, who was a CAS undergraduate, who's now working as a software engineer at Amazon, was part of another research team that built a tool to predict the likelihood of a legislative bill becoming a law. Julian De Niro, who's a former CAS undergraduate student who's now working as an actor in Hollywood, who's part of my team with Melanie Tosek, who's also a CAS student, and they analyzed 600 million tweets from Twitter that starts with the keywords I wish, I love, I hate, and they wanted to know what the world desired from the lenses of Twitter. Their work was published at the Washington Post. Anna Wang, who's with us tonight, she's a CAS student in my AI honors seminar. She will start researching if there's a relationship between types and quantities of illegal drugs used and recessions by applying machine learning to alternative data sources. Avery Greenberg, who's also a CAS student, have been experimenting using AI tool to find misinformation and hate speech. He actually spent the summer with me building a new course titled Predictive Analytics and AI for Social Good, which is going to be offered at the Computer Science Department at the Quran Institute. Most of these students are undergraduates in CIS, and they're affiliated with a lot of research with myself or with Professor Bloomberg, who's with us tonight. And they bring a lot of contributions to our research as faculty. I also would like to thank the Office of the Associate Dean of Students, Dean Richard Kalb and Rose Olivito, who provides funding from the DERF to a lot of these students. Now, going back to AI, I believe that specialized AI has left the field of science fiction, and it's part of our everyday life. And I think the question that might be relevant in our world today is, will AI ever outsmart us? So my general theory is that intelligence is the sine qua non, and it's the necessary ingredient for what it means to be human. And I believe that AI, especially specialized AI, would be able to continue to serve as an extension to human intelligence. However, I don't think AI would ever be able to replace a doctor or a teacher or an artist or a chef. We need human judgment and we need human creativity in AI design and deployment. AI might replace some easy jobs, but it might not be able to replace jobs that require critical thinking, persuasion, negotiations. It's also important to note that specialized AI, if badly governed, can represent risks for us, for humanity, such as data-driven discrimination, bias, deepfakes, misinformation, among others. And that is why it is important for us as a community to learn not only about the algorithms, but also about the risks as a first step to build the foundation for solid AI governance. If we go back to the question, will AI ever outsmart us? I believe that we might never be able to achieve general intelligence. And I think that it is because general intelligence will require culture, human experiences, linguistic human judgment, and human knowledge transfer. And this requires way more than faster machines and higher capacity memory. It will require that we first need to understand what consciousness is, what common sense is, and how the brain really works, and how it relates to the mind, and most importantly, what is a human soul? I'd like to thank all the students that inspire me and all of my colleagues every single day. We're learning a lot from you, and thank you for having me. I appreciate you. Thank you.